As we learn all of these different reactions, what we're really building up to is being able to do synthesis. And this tends to be one of the harder portions of the course, where we combine reactions to turn simple starting materials into complex products. So here's our first example, and we have this ketone product, and this is a retrosynthesis arrow. So this is basically saying, how do we make this complex molecule starting from this simple aldehyde, and we can use any other organic or inorganic reagent containing 4 carbons or less. So when trying to break these down, what you often want to do is find your starting material in your product if you can. So here is my aldehyde, the CH3 and the carbonyl of the aldehyde. And most likely, this is the same group in the product. So that kind of gives me a point to think about adding some things. Now, you might be tempted to just want to immediately think about adding this large group as a nucleophile to the aldehyde. But if you count, this has 1, 2, 3, 4, 5 carbons. So it's not quite that simple. So what else can we do? Think about your cuprate chemistry. In relation to the carbonyl, here's an alpha carbon, here's a beta carbon. This beta methyl group could have been added through an organocuprate. So let's kind of think about this in reverse. If that were the case, we would have this alpha beta unsaturated ketone plus this organocuprate. Now, again, kind of keeping a focus on the initial starting material that we want. Now we can break this apart. So now what we can do is break this up, and we have our aldehyde plus, I'm just going to do the organolithium compound. Now, this is kind of working this in reverse. We should always then go back and do the reaction in the forward direction. So start with the aldehyde. We add our organolithium compound followed by acid. What do we get? We get an alcohol. So this is why it's a good idea to do it in the forward direction. We actually need one more step. We need to do an oxidation. And I can just do something simple like PCC. Now I've oxidized that to the ketone. And finally, we can add the cuprate.